screenshot and send me. Okay, my dear Grayson, take one screenshot.
Sir?
Yes.
Okay, sir.
Sir, can you write and explain, sir?
I will explain concepts only today, only concepts, not sums.
No, sir. If you write and explain, sir, it will be easy for us to write the notes also, sir.
Yes, sir.
Notes means from the textbook itself, you have to prepare the notes. Actually, as a 12th class students, as higher class students, you have to prepare the classwork notes by yourself. You have to learn how to prepare classwork notes by yourself. Not only copying the notes via whichever I'm posting in the Google Classroom. Actually, that is not a correct method. You have to prepare yourself the classwork notes. That is the correct method. Okay, gradually it will be improved. Okay.
Okay, sir.
By watching the videos and by reading the textbook. Most of the students have no habit of reading textbook. They are not reading the textbooks. They ignore reading the textbooks. That is a blunder mistake that students are doing. You must read the textbook. It is important in learning subject. Only watching the videos or only listening the class does not help you in improving your subject. You have to read the textbook also. Read the textbook and understand the concepts whichever given in the textbook. Okay, habituate reading the textbook also, not only doing sums. Before the exercise, whatever the concepts were given in the textbook, you must read them well. Okay, my dear children.
Okay, sir.
Okay, sir.
Most of the students are doing this mistake. They are not reading the textbook at all. They won't see the examples also in the textbook. They won't give importance. They won't give importance for practicing exercises, for practicing example sums. They ignore the example sums in the textbook. Simply they prepare only textbook exercise sums. You have to read the textbook thoroughly. That is the main resource for you. Okay. Without reading the textbook thoroughly, you can't improve your subject. You can't improve your subject. Okay, my dear children, at least today onwards, habituate reading the textbook. Don't ignore reading the textbook. Right from the first line of the chapter, whatever the points are given in the textbook, read them carefully and thoroughly. And how many of you read the textbook? How many of you have the habit of reading the textbook? Tell me. Only Kevin Paul, Blessina.
Sir, I'll work out example sums and read, sir.
Yes. You have to inculcate.
Sir, I also do it, sir.
Inculcate the habit of reading the textbook, practicing the example sums, and moreover, miscellaneous examples, miscellaneous exercise also. Only because of time limit, we are not able to discuss every question in the textbook. Okay, because of the time factor, we are not able to discuss every question, miscellaneous examples or miscellaneous exercise sums, whatever it is. Time factor is there. Within the given time, we have to complete the syllabus also. Because of that reason, just I am explaining the concepts and few sums in the exercise. The remaining part is in your hand only. Okay. we have to learn by practicing example sums, whatever the questions which were not explained in the exercise, you have to practice them by yourself, and miscellaneous examples, miscellaneous exercise also. Nobody tell you, prepare these questions, prepare that questions like this. If you want to improve your subject, if you want to improve your knowledge, you must read the textbook. That is only the difference between the merit student and the average student. That is only the difference between the merit and the average student. Merit students, they will read the textbook also, they will practice the example sums also, they will practice miscellaneous examples also, they will practice miscellaneous exercise also. They won't leave any question. They won't leave any question. They won't wait for teacher's instructions. They won't wait for teacher's instructions. They themselves practice. Nobody tell them. Inculcate the habit of reading the textbook and practicing example sums. Okay. Okay, my dear children.
Okay, sir.
Today, we are going to discuss the concepts of exercise 4.2. That means properties of determinants. In the previous exercise, we have discussed how to find the determinant of a matrix by applying row operations or by applying column operations. Yes or no? But with the help of properties of determinants, we can find the determinant of a matrix easily. That is why this exercise was introduced. So you should learn the properties of determinants. This is an important exercise in the examination point of view also. There are totally 6 properties. I'm presenting these 6 properties in the form of video format. All of you watch the video, and Grison, once for each there I am presenting 3 videos. I prepared 3 videos on properties of determinants. Okay, for every presentation take a screenshot. Okay, my dear Grison, and send me
Sir,
it later.
for one video, I need to take one picture, sir.
One picture, one
Okay, sir.
screenshot. Okay.
Okay, sir.
Yes. See this video, my dear children. Watch this video. Hello, my dear children. Today we are going to discuss
Sir, you have to share your screen, sir.
determinants. In the previous exercise, we have learned what, my dear Grison?
Sir, you did not share your screen, sir.
I will share it. I will share it. Just now, I will share it. The definition of determinant of a matrix, and you solved the sums using the definition of determinant of a matrix. But to find the determinant of a matrix in easier way, we have to know the properties of determinants of matrices. Okay, my dear children, right. Come to the property number 1. The value of determinant remains unchanged if its rows and columns are interchanged. Okay, my children, that is det A is equal to det
of A transpose, that of A dash, where A dash is equal to transpose of A. So det A is equal to det of A transpose. This is the first property, okay, my dear children, of determinants of a matrices. So note here, see this note, if Ri is equal to ith row and Ci is equal to ith column, then for interchange of row and columns, we will symbolically write Ci by implies Ri. Okay, my children, this is a notation. Now come to the property number 2. If any two rows or columns of a determinant are interchanged, then sign of determinant changes. If you interchange any two rows or two columns, then sign of the determinant changes. Okay, my dear children, this is second property. Note, we can denote the interchange of rows by Ri by implies Rj and interchange of columns by Ci by implies Cj. Means we are interchanging these two rows. We are interchanging these two columns. Understood, my dear children? Right. Now come to
Understood these two properties, my dear children? First
Yes, sir.
property, if you take the transpose of the given matrix, suppose A is a given matrix, if you find det A and if you find the det of A transpose, both gives the same answer. That is the first property. Okay, det A is equal to det A transpose. We can use this property. Okay. Understood this first property?
Yes, sir.
The second property, what is the second property? If you interchange any two rows or any two columns, if you interchange any two rows or any two columns, then determinant of a matrix changes its sign. Its sign will be changed. Suppose in the first case, suppose A is a given matrix. If you find det A, for example, if you got 21, for example, if you got 21, in the given A matrix, if you interchange any two rows or any two columns, then if you find the determinant, then you get minus 21. In the first case, we get 21. If you interchange any two rows or any two columns, then we get minus 21. Understood this point, my dear children? That is a second property. If you interchange any two rows or any two columns, sign of the determinant will change. Okay. Okay, my children,
Okay,
by
sir.
practice, when you are doing sums, you can understand these properties easily. Okay, by practicing only, you can understand these properties. Okay. Now come to the third property.
property number 3. If any two rows or columns of a determinant are identical, it means all corresponding elements are same. Then the value of determinant is 0. This is a property number 3.
Understood this third property, my dear children? If any two rows or any two columns, if any two rows or any two columns are identical, means they same, corresponding elements are same, then the determinant of the matrix is 0. Then the determinant of the matrix is 0. This is a third property. Totally there are 6 properties. Okay, we had to remember these 6 properties, and according to the question, we had to apply the properties to find easily. Okay.
Okay, sir.
Okay, my dear children, remember these properties to calculate determinant of a matrix easily. Okay, my dear children. Now property number 4. If each element of a row or a column of a determinant is multiplied by a constant k, then its value gets multiplied by k. This is the another property. If you multiply any row or any column by a constant k, then we get the value is the k times the original determinant. Understood, my dear children? Right. Remarks means you must remember these points. By this property, we can take out any common factor from any one row or any column of a given determinant. Okay, my dear children, remember this one. You can take out any common factor from any row or any column. Now, second point to be remembered. If corresponding elements of any two rows or columns of determinant are proportional, means they are in the same ratio, then its value is 0. If any two rows or two columns are in proportion, okay, my dear children, then the determinant of the matrix is 0. Remember these points, my dear children. Right. Now,
Now see this fourth property. Fourth property. What is the property 4 says here? If you multiply any row or any column by constant, then the resultant determinant is k times the determinant. Or see here, remark, if any two rows are proportional or any two columns are proportional, any two rows are proportional or any two columns are proportional, then the determinant of the matrix is 0. And one more remark is, we can take out the common factor from any row or from any column, not from all the 9 elements. In the case of matrix, we take all common factor from all the elements, whereas in the case of determinants, we can take out any common factor from any row or from any column, not from all the 9 elements. In the case of a square matrix of order 3. In the case of square matrix of order 3, how many elements will be there? How many elements will be there in a square matrix of order 3?
9, sir.
9 elements. Okay, but in the case of finding determinant of a square matrix of order 3, no need to take common factor from all the 9 elements. We can no need to take a common factor from all the 9 elements. We can take out the common factor from any row or from any column. That is the property of determinant. Okay. You can understand these properties when you are practicing sums. When you are practicing sums, you can understand these properties easily. But you have to learn these properties. Okay. Have you taken a screenshot, Grayson?
Sir, for this video, I've already taken, sir.
Okay.
Come to property number 5. If some or all elements of a row or column of a determinant are expressed as sum of two or more terms, then the determinant can be expressed as a sum of two or more determinants. Okay, my dear children, if any row or any column elements are expressed as a sum of two or more numbers, we can express that determinant as a sum of two or more determinants. For example, let us take an example to understand this property. Okay, my dear children, right. Now let us take an example to understand this property. See this one, determinant of the matrix A1 plus lambda 1, A2 plus lambda 2, A3 plus lambda 3. These are the elements in the first row. B1, B2, B3, they are the elements in the second row. C1, C2, C3, they are the elements in the third row. If you observe these first row elements, every element is written as a sum of two numbers. So we can write this determinant as sum of two determinants like this. See here, first determinant, how we wrote a1, b1, c1. First numbers a1, a2, a3. We write a1, a2, a3. Similarly, b1, b2, b3, c1, c2, c3. Okay, my dear children. Plus lambda 1, lambda 2, lambda 3, b1, b2, b3, c1, c2, c3. Okay, my dear children. This is the another property. Now come to the sixth property.
Understood this fifth property, my dear children? If any row or any column, the elements in any row or any column are expressed as sum of two terms, then we can write the determinant of the matrix as sum of two determinants, as is shown in that example. In the first row, if we observe the elements in the first row, a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3. Second row, single elements b1, b2, b3, and third row also single elements c1, c2, c3. So this is the given determinant. To find the determinant of this matrix, we can split into two determinants like a1, det a1, a2, a3. We write second row, third row as it is, plus second determinant, the second numbers lambda 1, lambda 2, lambda 3, and we write the second row and the third row elements as it is. This is about fifth property. Okay, my dear children?
Okay, sir.
Yes.
Okay, sir.
The last property, very important property. Generally, we use this property to find determinant of a matrix easier. Okay, if to each element of any row or column of a determinant, the multiples of corresponding elements of the other row or column are added, then value of determinant remains the same. That is, the value of the determinant remains same if we apply the operation Ri implies Ri plus lambda Rj, or Ci implies Ci plus lambda Cj. If you apply any one of these two operations, the determinant of the matrix does not change. Its value remains the same. For example, let us take one example. Let delta is equal to det a1, a2, a3, b1, b2, b3, c1, c2, c3, and delta 1 is equal to, see, if you observe this delta 1, how we wrote this delta 1, a1 plus lambda c1. Here I multiplied the elements of the third row by k and added to r1. Observe it clearly. a1 plus k into c1, a2 plus k into c2, a3 plus k into c3. By applying that operation, I get this first row elements. b1, b2, b3. Second row, we write as it is. c1, c2, c3. We write c3 elements as it is. Then delta is equal to delta 1. Understood, my dear children? By applying the operation, c1 r1 plus by applying r1 implies r1 plus k r3. By applying all this operation, we get the elements in the first row. Understood, my dear children? Right. Remarks means please remember these points. First point, if lambda 1 is the determinant obtained by applying r1 implies k into r1, or c1 implies k into c1 to the determinant, then lambda 1 is equal to k into lambda. Means if we multiply the elements in the first row by k, then give it to k into lambda. or if we multiply the elements in the C1 by k, then we get k into lambda. Okay, my dear children. Now come to the second point. If more than one operation like Ri implies Ri plus Krj is done in one step, care should be taken to see that a row that is affected in one operation should not be used in another operation. Remember this point, my dear children. If any row or any column is affected, you should not use the same row or column in the another operation in the same step. Okay, my dear children. Right. A similar remark applies to column operations. Okay, my dear children. These are the six properties of determinants. We use these six properties of determinant to find the determinant of a 3 by 3 matrix without expanding along R1, R2, R3, C1, C2 or by C3. Okay, my dear children. Right. Now come to the exercise 4.2. See, first question.
Okay, my dear children, these are the six properties of determinant of a matrix. We use these properties to evaluate determinant of a matrix easily. We can use the previous knowledge also, but sometimes they will mention clearly in the question paper, they will mention clearly that find the determinant of the matrix by using properties. Using properties of determinants, find the determinant of the given matrix. In this case, you should apply properties of determinants, and then you have to find the determinant of the matrix. Okay, my dear children, especially most of the cases we use a sixth property. Most of the cases to find the determinant of a matrix, we use a sixth property. Means we add or we add any row or any column by multiplying the any row or any column to that row. Okay. Blessina, Kiran Raj, Ashwant Raj,
Yes, sir.
Grisan.
Yes, sir.
Ah,
Yes, sir.
okay. Okay. So these are the 6 problems here. Wi-Fi problem arised, Wi-Fi connection. Okay. Wi-Fi connection disconnected. So I tried to connect my data. That is why some technical problem arised here. Okay. Now see the exercise sums.
Using the properties of determinants and without expanding, prove that. Here it is mentioned clearly. We should not expand the determinant. We should use the properties of determinants. Okay, my children, we should use this method only. Prove that det x a x plus a, y b y plus b, z c z plus c is equal to 0. We have to prove that the determinant of this matrix is equal to 0 by using the properties of determinants, not by expanding it along R1, R2, R3, or C1, C2, C3. Understood the question, my dear children? Right. First, let us assume that lambda is equal to det x a x plus a, y b y plus b, z c c z plus c.
Understood this question, my dear children? You should not your previous knowledge to evaluate the determinant of this matrix. You should not use the previous knowledge where you have found determinant of a square matrix of order 3 in the exercise 4.1. You should not use that method. We should not expand the determinant of the matrix along R1 or along R2 or along R3 or along C1 or along C2 or along C3. We use this step at last moment only, at the last step only. Till then, you have to use properties, appropriate properties of determinants. Okay. This question, first question, det x a x plus a, y plus y b y plus b, z c z plus c is equal to 0. We have to show that determinant matrix is equal to 0. Okay, by using properties of determinants only. Okay, my dear children. Kevin Paul, Grayson, Kiran Raj, Blessina.
Yes, sir.
Yes, sir.
We should not use our previous knowledge. We should not expand the determinant of this matrix. Okay, along R1, R2, R3, or C1, C2, C3. We use this step at last moment only. Okay. So watch this video, watch this solution.
Just we are assuming the given determinant is lambda. Now we are applying this operation C3. C3 implies C3 minus C1. We get that is equal to det x a y b b z c c. Applying the given operation, we get this determinant.
So here we applied the column operation. We applied the column operation C1, C3 minus C1. Yes or no? C3 minus C1. We have to do this column operation in rough work. Previously we have done the row operation or column operation in rough work. Yes or no? In rough work
Yes,
we
sir.
have done it. Row operation or column operation. Finally, we wrote the result. C3 is elements we write as it is. Only third column elements are changing because we are applying column operation on C3, third column. Have you observed this in this step? Have you this point?
If you observe this determinant, C2 and C3 identical, same elements are there, same corresponding elements, A, B, B, C, C. Okay, my children. So its determinant value is 0 because the two columns of the determinant are identical. By using that property, we proved that the given determinant is 0. Hence proved.
Understood this last step, my children? Why this
Yes, sir.
determinant of the matrix is 0? Because C2 and C3, second column and third column are identical. We know the property determinant of a matrix. If any two rows or any two columns are identical, then the determinant is 0. We used that property. Understood this one? Kevin Paul, Grayson?
Yes, sir.
Yes, sir.
Messina, Yashwantram, Jerome, Jayshraj, Janani.
Yes.
You have to learn these properties well and apply them appropriate property. Okay, now come to the second question.
Understood, my dear children? Come to the question number 2. Using the properties of determinants and without expanding, prove that A minus B minus C minus A, B minus C minus A minus B, C minus A minus B minus C is equal to 0. Here also we have to prove the determinant of this matrix is 0 by using the properties of determinants only, not by expanding. We should use that method only. Remember this point. Keep this point in your mind, my dear children. Right. First of all, let us assume that lambda is equal to, so delta is equal to det A minus B, B minus C minus A, B minus C minus A minus B, C minus A minus B, B minus C. We assume that the given determinant is delta. Now we apply these operation, this operation C1 implies C1 plus C2 plus C3. Then we are adding the C2 elements and the C3 elements to the C1 only. Here only C1 is changing, not C2 and C3. We write C2 as it is and C3 elements as it is. Just here C1 is changing. How it is changing like this? C1 plus C2 plus C3. We have to add all these elements to C1. So I wrote this step: A minus B plus B minus C plus C minus A. See this one, B minus C plus C minus A plus A minus B. See this one, C minus A plus A minus B plus B minus C. These are the elements in the first column. We write second column elements and third column elements as it is. Okay, my children, that is equal to, by simplifying these expressions, we get here 0, here also we get 0, here also we get 0. It means all the elements in the first column becomes 0. Second column elements B minus C, C minus A, A minus B. Third column elements C minus A minus B, B minus C. We write these elements as it is. So its determinant value is 0 because each element of C1 is 0. If each element of any row or any column is 0, then its determinant is 0. Okay, my dear children, hence proved. Understood, my dear children? Right. Now,
Sorry. Understood this question, my dear children? Understood this question?
Yes, sir.
We applied here.
Yes, sir.
Here column operation. After that, we have applied column operation. That is the sixth property. We have applied sixth property here. We added C2 and C3 to column C1. We got C1 elements. We wrote C2, C3 elements as it is. After simplifying C1 elements, we got all the elements in C1 is 0. So we know the property. If all the elements in any row or in any column is 0, then the determinant of the matrix is 0. So by applying that property, we have proved that determinant of the given matrix is 0. Okay. See here, we have not expanded along any row or any column. Have we expanded in the determinant of the matrix along any row or any column? Have we expanded the determinant of this matrix along any row or any column as we have done in the exercise 4.1?
Yes.
What we have done here, we used the properties of determinants. Okay.
Come to the question number 3. Using the properties of determinants and without expanding, prove that det 2, 7, 65, 3, 8, 75, 5, 9, 86 is equal to 0. So we have to prove that the determinant of this matrix is equal to 0 without expanding. We have to use the properties of determinants only. Remember that point, my dear children. You should use that method only, not the expanding method. First of all, let us assume that the given determinant is delta. So let delta is equal to det 2, 7, 65, 3, 8, 75, 5, 9, 86. Now we are applying this operation. C3 guys, C3 minus 9C2. Then we get here which column is changing? Only C3. C1 and C2 elements we write as it is 2, 3, 5. First row, first column elements 7, 8, 9. Second column elements as it is. Here C3 minus 9C2. We are using this operation. So I wrote here for rough work C3 minus 9C2. Okay, C3 65, 75, 86. I wrote the three numbers as it is minus 9C2. Multiply the elements in C2 by 9. Then we get this statement. By simplifying these numbers, we get 2, 3, 5. So these are the elements in the. Okay, my dear children. Understood this step, my dear children? Right. If you observe this determinant, C1 and C3 are identical because 2, 3, 5, here are 2, 3, 5. Corresponding elements in C1 and C3 are identical, same. Therefore, its determinant value is 0 because the two columns C1 and C3 are identical. Understood, my dear children? Right.
Yes, okay, my dear children. Understood these examples also? Question, exercise,
Yes, sir.
questions 1, 2, 3. Okay. You prepare the classwork notes by yourself by watching this video. Okay. Can you prepare the class by yourself?
Sir, will
The
this
classwork
video be
notes.
posted, sir?
I will post this video. I will post this video. Okay.
Okay, sir.
I will post this video in the classroom. Please watch the video again. Prepare the classwork notes because most of the students are not watching the video. Simply in the notes which I am posting in the classroom. Yeah, they are not watching the video again. That is why I am showing this. I presented this video and you prepare the classwork notes by yourself. You have to learn how to prepare your classwork notes by yourself. You have to improve this system. Okay. Now the time is
Okay,
10
sir.
past 46 minutes. 10 past 46 minutes. Now you can leave the meeting, my dear children. Take rest. Take care of your
Thank
health,
you.
my dear children. I will post
Thank
this
you,
video.
sir.
I will post this video in the classroom. Please watch the video again. Please watch the video again. Prepare the classwork notes by yourself. Okay. If any doubts are there, then ask your doubts and get your doubts clarified. Then your
Okay,
knowledge
sir.
will be
Thank you, sir.
improved. Simply copying the classwork notes, whatever posting in the Google Classroom doesn't improve your knowledge. You have to prepare yourself. You have to prepare the classwork notes by yourself, by watching the videos or by listening. Okay.
Okay, sir.
Yes. Okay. Now you can leave the meeting. Take rest. Take care of your health, my children. Stay at home. Stay safe. Use a sanitizer
Thank you, sir.
frequently for cleaning your hands and maintain social distance of 2 meters from others. And do your work sincerely and seriously.
Thank you, sir.
Yes. Thank you, my dear Joseph. What, my dear Ayush? Yesterday you have not attended the class. You have not attended the class. Ayush?